So yeah, this happened yesterday evening. So I'm sharing an Airbnb with my coworkers, and we had some beer, and afterwards we had some more colors in the slides, which is nice. So yeah, I'm Timo. I'm actually CTO and co-founder of Giant Swarm, and we run cloud-native infrastructures for our customers, which are mostly big enterprise companies. So that's like a little bit the perspective I have on this cloud native infrastructure. Not from a, like, we're a startup, but we're not creating a product for startups, we're creating a product for enterprises. So that's also a little bit the focus of my my talk. But if you're not working in an enterprise, I hope I also have some interesting facts for you, and that my talk helps you with your cloud native infrastructure. Yeah, we're doing this for Vodafone, for Adidas, and for Shutterstock, for instance, worldwide, which includes China. So we're running Kubernetes clusters in the Chinese region of AWS for Adidas, which is interesting. And different from other regions because suddenly all the crypto parts are missing and replaced by Chinese services. And so yeah, we're doing a lot with Vault there and replace some parts that we can actually do with KMS in a regular AWS installation. And yeah, we made some interesting experiences there. Who of you is using Kubernetes? Who is using Kubernetes in production? Cool. That's very good. So I don't have to explain a lot about Kubernetes itself. I just want to give just a brief overview of cloud native, what I think are the essentials of it. I think I don't have to explain what cloud native is actually. And then I want to show you how a cloud-native stack could look like, because your cloud-native stack might look different than ours, and also everybody, like every customer has a different cloud-native stack. So we're helping our customers also to build on top of the Kubernetes clusters. We have solution engineers that help them to create their pipelines and to do the logging and monitoring and all this stuff. And this is not always the same throughout the customers. It's great that we have some flexibility, that there are different tools for different use cases. So I'm just like making an example here. And if you want to replace FluentBit with FileBeat, or want to use Loki for logging, that's totally up to you. And I won't have the time to just dive into all these tools and explain all the differences. And I think there are lots of talks that dive into those different topics and explain a little bit better what the differences between the tools are. So the focus of the talk is a little bit more about, like, what are actually the challenges that we are facing with all these container applications that we are running, and also with the clusters underneath that we're running for the companies. And so how do we deal with the 24/7 management of those of this infrastructure, and how do we deal with that with a small team that we are, and then managing hundreds of Kubernetes clusters. So yeah, what is cloud native? First of all, the most important part for me is that we have composable building blocks. And when Vogel said this on the recap of 10 years of AWS, that it's important to build these kind of composable building blocks. Like, you can use Elastic MapReduce if you want to have Hadoop on AWS, but if it doesn't suit your use case, or you think that's too expensive for me and I just want to do just some part of it, you can still start EC2 instances and build your own Hadoop on AWS and use S3 to store your data. And similar, that is with Kubernetes. You can use a deployment to have a rolling update strategy of a replica set that keeps a certain amount of pods of your service running, but you can also just start a plain pod yourself if you want to do something else, right? So these things are composable. You can always fall back on the lower level and do something different if, for instance, the rolling update strategy of the deployment doesn't fit into your use case. You can just like use a replica set and then do your own upgrade process. So I think that's an essential part of the cloud native infrastructure, and actually Kubernetes is just the foundation to create platforms on top, and you see that there are serverless frameworks on top of Kubernetes and pipelines and all different tools where actually the developer doesn't have to care that much anymore about I'm running my software on top of Kubernetes, but has a simpler interface yeah, just to make the life of the developer easier. The other part is that for Kubernetes, it's essential to have a declarative approach, how to define how your infrastructure should look like. So you have a manifest where you define, okay, I want to have like 5 pods running of this and that service, and you define the ports and everything. And the controllers within Kubernetes constantly check what is defined by the user and what is actually happening. And there's a control loop continuously trying to bring the desired state into reality and checking the actual state if there is a difference. And this asynchronous pattern is kind of key to Kubernetes and how it works. And we are also using that pattern in terms of writing our own operators to manage the infrastructure. And sometimes it's really interesting to see how you define something. Like let's say I want to have a cluster on AWS with 3 nodes, and then we have an operator that translate this into sub-resources. For instance, we need to have a CA for the cluster, a root CA, and we need to have a certain set of certificates. So we have a certificate operator that would talk to Vault and create these certificates. And then we also have a cluster operator that kind of says, okay, I also want to have an ingress controller installed on the cluster. We have the AWS operator that talks to the AWS API to create a CloudFormation. And so there's a delegation of tasks that are happening in throughout these control loops, similar to how deployment, replica set, and pod are kind of working together. And it's all asynchronous. They're all independent. So if the controller that takes care of the pod is not there, the rest of the chain would happen. And once the controller is up again, it would do the last step. So sometimes it's interesting how such a cascading, like if you manage to spin up 100 Kubernetes clusters at the same time, it's interesting to see how these micro operators kind of translate that into reality. Yeah, and the other part is immutable infrastructure, and you might have heard this before. So that's basically containers. So you spin up a container really fast, and you don't have to install something, but you have a snapshot. You have an image of what you want to run, and you can do the same thing for the underlying operating system. So if you use something like Container Linux, you have a very small Linux that just brings like Docker and the necessary things to run containers, and you have a short definition of how the server is configured, and you would not install an agent that would install something else on top of it. Like config management has done this in the past, and you know, some people might have been burned by those kind of tools, and you know, Chef and Puppet, and I also consider Ansible and Terraform are kind of in that corner. They claim to be declarative, but in many cases I've seen Ansible definitions that are actually scripts, and they don't work as declarative infrastructure. Yeah, that's the basics of cloud native infrastructure. And one core belief, at least for me, and I think also for many in the community, is that we believe that infrastructure should be open. So it's an abstraction layer on top of the cloud providers that is actually open. So if you, I don't know, switch a company, it's still a Kubernetes. If you switch a provider, it's still a Kubernetes, and it's open, and many companies are contributing to those projects instead of, you know, everybody building their own black boxes. Some numbers, I had to look them up. There are now 35 CNCF projects in different stages. These are the ones that are have graduated already, yeah, I found 277 charts in the Helm community repository. That's a lot, but there are also not necessarily cloud native projects in there. For instance, there's also a Factorial server that you can launch on your clusters. But yeah, that's a lot of projects and a lot of software that you can run on top of Kubernetes. So how could a stack look like? I mean, obviously, you first start. You want to run a microservice. You need to have some configuration, some secret management. You want to register your service so some other service can find this service, and you also want to be able to find other services. And that's basically a basic offering of Kubernetes. Kubernetes offers a lot more, and core DNS on top helps you with that service discovery. And so if you want to run this simple microservice, these are already the components that you need to run in your infrastructure to have your Kubernetes master, which is the control plane of Kubernetes, and then have some nodes and run some agents on top of it. Yeah, there are probably more. There's also Docker and or other things involved there. As I said, this is just an example, and I just want to show how many things you need to run to actually run a simple service. And yeah, on day 2, you also think, okay, I want to have some metrics. I actually want to see what's going on with my service. If you have many services, you also want to have some tracing. This adds a lot of YAMLs to your configuration. So for instance, our Elastic stack would look like this. You have many Kubernetes manifests, and yeah, you probably put them in a package together, and Helm is one way. There are other ways to do this. So with Helm, you can template those manifests because you want to run those the stack on maybe different environments. So some things of the manifest need to be configurable, and so there's some templating in there. And yeah, you have some repositories where you can store those charts, and then you can easily install this on your cluster. And it's an example how we first started the current diagrams are way too complex, so I'm using an older one. But I think so. The engineer merges a PR on GitHub, and then the build is triggered. We're using CircleCI. When CircleCI is ready, it pushes the container here to Quay. Quay has an application registry where we can not only store the Docker images but also the charts. And then CircleCI, once that's done, CircleCI creates a GitHub deployment event, and then we have a component in the cluster that actually watches the deployment event, and then would talk to Tiller and install the chart on the cluster. The reason why we're doing this, I mean, the nice part here is that actually the continuous, the build pipeline is separated from the deployment pipeline. So we could switch out CircleCI without changing the way how we install things on the cluster. But the reason why we created this was actually because we have many clusters that are behind firewalls, whatever. We cannot push from the outside. So we run a lot of clusters for customers on-premise and in different AWS accounts, and we cannot, from a central point, from a giant swarm point of view, push all our updates into the clusters. We actually need to have a daemon running inside of the clusters that pulls something. So that's why we have the Draughtsman here. And this is day 2 of your cluster. So now you have, I shrinked the master components into that green box, and obviously also the logging, the metrics, and the tracing are multiple components that you have running in the control plane. And usually you also have another agent on your nodes. So, and the day after, day 2, you probably heard about Istio or other service meshes. So you can also use Linkerd, you can also use like Open Policy Agent if you want to do policies. So Istio brings a lot of stuff. The surface, like the SDK of Istio is quite huge. I don't know, it's like 60 resources or something like that that you add to Kubernetes. So there's a lot to learn. It has also has a lot to offer. So you can basically have all the network functionality that, like for instance, libraries like Hystrix have added to your service in the past. You can just add it through Istio to your services without the services even knowing about that. So you can have an old service that speaks HTTP, and Istio can upgrade it to actually speak HTTP2 or gRPC with another service without the service noticing anything about this. It can add authentication to every service. You have mutual TLS between your services, things like that, and it offers a lot of capabilities in regarding policy enforcement and observability. So regarding networking, you can read out all the stats, which service is communicating with which other service, how many connections are coming in. Those kind of things are provided by Istio by default, again without the need to, for instance, have a library to expose Prometheus metrics within your service. So it does that mainly by injecting a reverse proxy into all the pods. That's the Envoi project, and Envoi is in there because it's fast and but dynamically configurable, which is hard if you do something very dynamic with Nginx or HA proxy because of all the the reloading, it's not fun at some point. So Envoi is the better tool here, and that's why the Istio project is using Envoi. And as you can see here, Envoi is exposing metrics, and also it forces all the traffic going out also through Envoi. So it's like basically IP tables, rules that define within the network namespace of the pod that everything must go through Envoi. And as I said, the service doesn't need to know about this. And then Envoi is actually communicating with the Istio control plane, which means it sends attributes, which is like the observability of it, and also receives the configuration. Like if you do something like a canary deployment, the configuration is sent through the pilot component of Istio, which kind of does the smart traffic routing. The reconfiguring of the fleet of envoys that you're running is done through a component in the control plane called pilot. So it just got even more complex. As I said, there are components like Citadel and the pilot and the mixer by Istio and the control plane, and then you also have the envoys injected in all of your pods. But with our customers, we actually figured out it's not only one cluster that we need to run, because security says, okay, yeah, but development testing, please don't mix that with production. So that's how most of the customers start. They say, okay, we have one team that they are going to start with a project. They want to run it on Kubernetes, so we need to have 3 clusters, which adds to the complexity, obviously. But then multiple teams do want to use Kubernetes. Sometimes also there are compliance issues, especially if secret data is used in a company, like, I don't know, Adidas has some sneakers and they're going to launch them, so this is not going to go on AWS. This is on-premise, and they won't put this on AWS. And so some teams need to run on-premise, and some teams need to run in the cloud. But also what we figured out is that if you have multiple teams on the same cluster and then want to do an upgrade of the Kubernetes cluster, you need to synchronize all these teams. And some of the teams are like, yeah, but I don't have budget for that because I need to switch out this component because it doesn't run with the latest Kubernetes version anymore, or I need to upgrade my stack or my pipeline or whatever. So you kind of need to find a point in time where every team is ready to upgrade the cluster. And this is hard. And so people start multiple clusters for different teams. So we already have 12 clusters here. And then, as I said, then you have the same thing on premises and in different regions and maybe on different cloud providers. And yeah, it's just very, very complex. And that's why we have a control plane of the control planes, which means we're using a Kubernetes to actually manage all the Kuberneteses. And because as I said in the beginning, I don't want to do this with Terraform, and this would get totally out of hand with a small team if I would do this with Terraform, because I want to have these operators that are continuously looking what's going on, that are continuously checking, okay, my desired state doesn't match the actual state. I need to fix this certificate, or I need to check what's going on with the ELB in AWS. So it's constantly changing the infrastructure into the desired state, and that's important for us. That's why we're writing operators. And yeah, complexity is not going away. If you have entropy, it's only going to rise. That's the second law of thermodynamics, and I think that's the case here as well. We're kind of reducing the complexity for the developers, but it's not necessarily simpler for the infrastructure. And yeah. So the thing is, I mean, for me it's easy because we provide Kubernetes as a service, and obviously I can say, yeah, don't do it yourself. But we have seen many companies doing it themselves for 18 months or something, and then they called and said like, yeah, we have downtimes, we need more clusters, we know we cannot handle this, we have like 5 people in the team, they're completely overloaded, it's not fun anymore, now they want to have Istio on top, we're still on Kubernetes 1.9, all these problems. And so I don't care if you become a Giant Swarm customer or use somebody else, but please, if you're not a strong tech company, don't do it yourself. It's easy to use like kops and say like, hey, cool, the cluster is running. But there will be the point when you go into production where you suddenly realize there are many components, and it's hard to keep up with all those components, to hire the experts that kind of know all these components. And there's still a lot of stuff to do once the Kubernetes is there. What you need to do together with the team to actually enable them to run everything. So running the Kubernetes yourself is really not something you should do, and you should definitely use a managed service from some provider. Yeah, as I said, we are managing Kubernetes with Kubernetes, and I just wanted to this is a random example, but I basically explained this already. But with the customer resource within Kubernetes, you write out a spec of something, and you have a status of it. And an operator can actually watch the spec. So that's the desired state. That's how things should be. And then it reconciles with the Azure API here, because it's the Azure operator. And if it doesn't match, it tries to change it. And at the same time, it updates the current state. So the status of how things look within Azure. And this can be a chain of operators doing things. And that's how our control plane works. And we have already a bunch of components that we install on top of the clusters, which is kind of the default of a cluster, where we have an ingress, obviously, because like people want to launch something on top of the cluster and should be available. But we also have certain exporters, mainly because we need the observability into the cluster, because we're wearing the pager. So we want to see what's going on within the clusters, and we also have some management components that we launch onto every clusters to be able to upgrade them, and also to install new applications on top of it. And what we have recently developed is an app catalog based on a Helm chart repository. Actually, it could be any storage that has tarballs of charts in it, and an index YAML definition of what is in there. And many of the other tools like Rancher and Google Kubernetes engine have similar things, where you can actually install things more easily on top of the clusters. And actually, I can do a live demo and don't need to do the video. So I can look here. So I created a cluster. So that's basically a cluster that the cluster view in our web interface. You can actually even check here. You can upgrade the cluster. Just wanted to show that quickly. So, but the thing that is new is that you can browse apps, and within the control plane you can actually configure different app catalogs. So you can, this is the community catalog, but we can also add our own catalog where we provide some applications where we add an SLA to the customers. So within the teams that we work with in those enterprises that are usually the cluster admins that kind of know Kubernetes very, very well and train the development teams how to use the pipeline, or to build the pipeline and then help the teams to actually connect to it and launch the applications on top of Kubernetes. They do a similar thing. They kind of offer a monitoring, they offer the pipeline, and they actually talk to us and ask us, like, can you do this for us? Like, I don't want to run this Prometheus. Can you just do this? So we're going to add our own catalog there with SLAs for, you know, Prometheus, a logging stack, and Kafka most likely, and other components that we see our customers are running. But this is like the basic catalog, the Helm catalog, and then you can, like, for instance, if you want to install the Prometheus operator, you could just go here and configure it and install the application, and that's all. But the nice thing is you can do this across multiple clusters. You can keep those applications up to date on multiple clusters. And this is, again, configuration management that you need to do. You need to keep all these clusters that you might run in the future up to date with the applications that are running on top. In the first place, with these components, we started out with, like, immutable infrastructure. So the image comes up of the master and it installs a certain version of the exporter, similar to the kubelet or the application, the API server or the controller manager came in a certain version of Kubernetes. We also kind of locked them down to later then realize, yeah, but we need to roll the nodes all the time. We do a small update of any of those components, which isn't even necessary on top of Kubernetes, because you could just, like, launch a new container and you have a system already where you can do a rolling upgrade. So why do we need to roll the underlying operating system nodes within AWS, for instance? So we wanted to just have an independent life cycle of these things that run on top of the clusters that we still manage for the customers. And yeah, that's the same for the applications. And for Joe, I can actually also install the Factorial Server. Should we use that? Actually, I wonder if I can get my son play with you. Cool. Actually, I didn't know this until today, that there's a Factorial Server. Let's go into. Yeah, and that's what I explained. So what you can see here, the yellow and green things, they are basically coming with the immutable infrastructure and with the, that's our Kubernetes as a service part. So we have a certain release. So let's say Giant Swarm 746 or something like that, and then this is reproducible. We know if you install a cluster with that version, exactly what kind of versions of these components are in it, and it's important that it's reproducible, because we want to run integration tests, conformance tests. We want to really make sure that this release works for our customers, and we need to reproduce that, be able to reproduce that. And also, if this is running in production, and you have a certain problem with a certain version, we can just reproduce it. We create a new cluster, and on the same hand, the customer can also do this. Like, we have some customers that have integrated cluster creation into their integration tests. They start a certain Kubernetes version through our API to run their test, and then they tear it down afterwards. And it's just very important that this part comes kind of immutable and is reproducible fully, and that not something is switched out that you don't have under your own control. And then the pink and red boxes, these are the components that are actually coming through the app catalog and that are independent in terms of, it's actually half true, because one operator also takes care that I think these things are kind of in lock with them, because they are the essential components. But then the other components, like the Prometheus operator that I installed, they are independent of the version of the cluster itself. Yeah, and as I said, this diagram is much more complex now. It's not as simple as having some GitHub events and then one daemon, lots of operators that are doing things. It's all open source, and yeah, it's early stage, but it's based out of the experience that we made with the first iterations of how to manage the applications on top of Kubernetes. So I always like to talk about a few private things in my talks. People know that I like to bake bread or play the piano, or how I became root on my heating actually and hacked it. So I was sitting on Sunday and doing some slides, and my son came to me and he was like, "What are you doing?" And I was, "Yeah, I'm preparing slides for my talk." "Oh, what tool is that? Can I have that too?" And then I was like using Google Slides, and he has a Google account, so he sat down and created a slide deck for his Moon project, the Moon program that he's going to do, and this slide came out of it. And I found this like fantastic, because it's like software development, pure software development. So 11-year-old boy already figured out how reality looks like. And very important, if the rocket is already, on its flight, it's really bad that he forgot about the sweets. So yeah, he's a big fan of Kerbal Space Program. And anyway, yeah, we're kind of continuously upgrading, releasing new versions of Kubernetes. We're also adding some new features. And yeah, as you saw, quality is varying, and sometimes unexpected things are happening, and we are wearing the pager. It's very important. Like, how can we keep everything up with such a small team? And yeah, some numbers regarding that is like roughly we had 70 release versions of the Kubernetes version, which is sometimes features, sometimes Kubernetes versions itself. So minor versions are usually, patch versions are usually rolled out automatically. We give the customers control over switching minor versions, because there are also some differences. Usually some things are deprecated or removed or renamed and things like that. So we cannot just like under the hood upgrade the Kubernetes version for the customers. So that's what the customers are doing themselves. And we do this on 3 different providers. So we have the on-premise, Azure, and AWS. We also have Slack channels with all our customers, and sometimes funny to see, because some of the bigger enterprises don't have a Slack, and they suddenly find themselves in a Slack channel with Giant Swarm, and they're actually talking to each other, and we're like, okay, you didn't mean us, you mean you're talking to your colleague that you don't have any chat tool internally. Anyway, that's a huge problem. I mean, keeping false positives of alerts, and like if you roll fast with continuously having new releases, it also happens that you release something and then you like get fired from like all these clusters, and so yeah, currently we're on call, like each engineer is on call every second week for 24 hours, and sometimes it's fine, sometimes it's a pain in the ass, and yeah, I think at some point I can give a talk about on-call being pain in the ass. But yeah, we try to handle this, and one thing is, once you're on call, there's an alert, you actually start a thread in the incident channel. Once we found it, we actually document everything into a GitHub issue, which we call the postmortem. So it has a postmortem label, and then in the team planning, we actually distribute those postmortems into the teams, and they come in with highest priority because we don't want to see it again. So somebody is taking care as fast as possible to actually remove this problem. So this was the duct tape, and this is the way how we kind of want to get rid of it for real. So the team takes care that we either, if we don't know how to fix it, have more metrics and more visibility into the problem, or that they fix the problem itself. And we actually have a work in progress limit of 5 postmortems per team. If there are more than 5 postmortems in a team, the team is working on nothing else than getting rid of these postmortems. Yeah, and this is like 40, 60, 80. And these are months, and these are the number of postmortems that we're getting into teams. I also played a little bit with providers. Most of the customers are on AWS, so that's why we see most of the problems with AWS and less with the others. With KVM, we also see a lot of problems because it's on-premise, and the environments differ quite a lot in terms of networking, in terms of storage. So that's always a challenge. And yeah, I also tried to do this per component, and there you can see like many of the components, except the AWS operator that is developed very heavily, which is like spikes there, but you see problems all over those components. And yeah, we consider ourselves the SREs of the customer, and so I just want to just quickly go through team culture. This is us in on Mallorca last year in September. We're completely remote, and so we're trying to meet each other every half a year to actually have some fun together and to do some work together. And yeah, we're going to meet next week in Barcelona on Cubecon. There are many new colleagues we haven't met yet in real life, so it's going to be fun. And we're actually taking the train. A couple of people from Belgium, France, and Germany are taking the train together, which will be fun. Yeah. So how to keep up with everything? As I mentioned, there are many components, and things are released every other day. New things are coming out. How can you keep up with all this? So we have some cross-functional teams. You see the different roles. These are customer, like solution engineers. These are SREs, platform engineers, the product owner, some front-end engineers, and the thing is, all of them have some labels of like special interest areas that they're interested in, and so we have, similar to the Kubernetes project itself, we have special interest groups within the company where people organize around some of the topics. So I don't know if you're familiar with like how Spotify organizes their product engineering. Then you find something like guilds and chapters that's kind of similar. That's just a way, if you have these vertical teams, to have some horizontal communication between those teams. And people that are interested in certain topics can kind of find best practices and find some consensus across teams to make life easier. Yeah, for, I don't know, the SREs are in SIG infrastructure, so they kind of agree on what's the next step in the infrastructure. And for me, that's interesting because I can also filter out and figure out, like, does that team have any, everybody, like in every SIG is somebody from that team? Or like here you can see that nobody from the cast teams is actually in content. So we will not get any content on the block from the cast team. So maybe I need to find somebody who joins the SIG content. And yeah, Joe, one colleague, created this in Neo4j to actually visualize the relations between the teams in the SIGs. Yeah, that's crazy. And it looks like chaos, but it is not. So yeah, that was my talk. Thank you very much. We'll be around. Joe will give a talk tomorrow, and Tobias will give a workshop on Thursday. And thank you very much.